Nothing is something. Recently, I returned from a vacation in Italy, and I noticed that the ground floor was numbered 0. And in the United States, the ground floor is numbered 1. Well, someone told me that 0 is nothing. So does the ground floor not exist in Italy? Or perhaps I really was in Italy. I was somewhere in Hogwarts Academy. Well, let's look into this in more detail. Here we have a picture of a woman. And if we look at the picture on the left, we can either see a young woman or an old woman. If I darken out, get rid of the chin of the older woman and change the hat a little bit, it becomes more obvious that it looks like a younger woman. But this tells us that our own mind can see things differently. What about if we're trying to show something to somebody else? Well, recently I was looking at a video called 0 to Infinity on PBS. And it seemed to convey to me that they thought that 0 was nothing. And to illustrate this, they gave me some examples. If I took the number 44, I can make the 40 a 400 by inserting a 0 in the tens place. And it was implied that because 0 is nothing, that 0 must be a placeholder. But I could do the same thing with the 1. And the 40 becomes a 400. So this confused me a little bit. So then I looked at this concept that 0 is nothing, and I said, well, if that's true, then 2 to the 0th power and 0 factorial should be 0 because they consider products that should be involving 0. But in actuality, 2 to the 0 and 0 factorial equal to 1. Well, I think I'm going to have to look at this a little bit further. Well, then they also made the claim that 0 is the center of the number line. I believe it's 5. Why? Because if I use the Hilbert Hotel approach, which was discussed in the video, there is, for every number on the left, there's a number on the right, for both 0 and 5. So now I am really confused. I better challenge what I've been shown. So now I looked at this from the number 1. I noticed that the way I created my numbers was adding 1 to the preceding number. So 1 plus 1 was 2, 2 plus 1 was 3. And since 0 precedes 1, then 0 plus 1 must be equal to 1. Well, let's take this a little bit further. I know that 2 is equal to 1 plus 1. So if I replace that green 1 with 0 plus 1, I then get 0 plus 1 in parentheses because I'm associating those values plus 1. But now if I associate the two 1s, I get 0s plus 1 plus 1. And that 1 plus 1 I can replace by a 2. And so now I have that when I add 2 to 0, I get 2. So I'm drawing the conclusion that the reason why 0 plus 2 is because 0 is the number before 1, and it's used to make numbers. Now, let's look at the numbers from 1 to 12 using our base 10. If I decide I want to create the numbers by eliminating the 0, then 10 would be 1, 1, 12 would be 1, 2, and 12 would be 13, 1, 3. As you see, I made a mistake in the pronunciation. Okay, so 11 would be 1 times 9 plus 1, which is 10, and 12 would equal to 1 times 9 times 2, which is 11. So 11 and the base 9 is the same as 10, so on. Now let's look at this in a different way. I have the numbers from 1 to 12, and I replace the 10 by 1 plus a number holder, which I'll call X. And then 11, I know this is 1, 1, and 12 would be 1, 2. So I see this x, 1, 2. Well, I've seen that x, 1, 2 before on the previous page, and that x was 0. X, because x was the number before 1. So now I again see that 0 was not really, it could be used as a placeholder, but it's somehow dependent, the value of 0 depended upon this way I created my numbers with 1. And I thought, I'm not really sure of this. Maybe I'm pushing it. So let me go back further. And if I went to 9, 9 would be 1, and it would be the number before 0, it would be -1. So I have 1 concatenated 1, which is that line, the -1, and 10 minus 1 is 9. I've seen this before. Oh, yeah, in Roman numbers. 9 was 1, ix. I was the number. I before x becomes a minus sign. I'm feeling much better about how I'm looking at this stuff. Okay, now let's see what happens when we look at this in some other problem. I want to multiply 50 times 700. So I can replace the 50 by 5 times 10 and the 700 times 7 times 100. I can use the commutative property to get the 5 and 7 together and the 10 and 100. And I get 35. And 10 times 1,000, using this exercise I had before, I'd end up counting zeros. Okay, so now let's see how we can use this with multiplication. Okay, so if I multiply 5,555 by 5,005, the way we've been taught in school, okay, some kids I notice will be multiplying by the 2 zeros in there, getting rows of zeros. And I put in light what would really be there in terms of what we're multiplying, but we've usually left those yellow zeros out because it makes the thing easier to look at. But if I now use what I've just shown you above, I'm multiplying 55,000 plus 5 times that number. So first I multiply by 5, which is the second number, and then I multiply by 5,000, and I get the next number down. And I add the two, and I get the same answer. By the way, I was using the distributive property to do this. Why? It takes less time, it's faster, and I'm more likely to get the right answer. Let's look at some more. On a clock, if I add 5 hours to 12 o'clock, I get 5 o'clock. It's like 0. Adding 5 to 12, I get 5. And 12 is not 0. And if I take half of 12, I get 6, halfway around the clock. Why does 12 act like 0? It's the number before 1. Now let's look at this modulo work. And what we see is if I put the numbers 1, 2, 3, 4, 5, 6, and the circumference of the unit circle is 2 pi, then 2 pi would be where the 12 or 0 would be. Well, if I look at the spacings, then the spacing between the 6 and the 6.28, I'm not getting a unit spacing. But now, look, if I replace those numbers in radians by the numbers in degrees, using a scaling factor of 0.0174, etc., now it looks right to me. So this now makes me think about 1 again, is that 1 is not sort of 1. 1 sheep is not the same as 1 cow. Okay, now let's go back looking at 0 to 1. And the reason why I showed you that information on the 1 was because I wanted to show you that I had created a new problem that I had to solve that may have taken my whole argument apart. Now, we know that 5 plus 0 is 5, and 0 times 5 is 0, and this is because 0 is nothing. Okay, but if I look at 1 and use multiplication instead of addition and exponentiation, 5 times 1 is 5. 0 and 1 are the identity elements. That's a way of getting around this zero is nothing comment. And if I raise 1 to the 5th power, I get 1 back again. Multiply 0 times 5, I get 0. So this 0 and 1 seem to have something in common. Okay, now let's look at multiplication and exponentiation. If I define 3 times 5 as adding 5 3 times, 2 times 5 would have 2 5s, 1 times 5 would have 1 5, and 0 times 5, well, you'd say no 5s. Okay, but if I then went to 5 to the 3rd power, I'd have 5 times 5 times 5. To the 2nd power, 2 5s. To the 1st power, 1 5. And we're going to have 5 to the 0 power. Well, I'd come up with 0 if I use the same logic. But now let's go over to redefining addition and multiplication, or multiplication exponentiation. 3 times 5 could be written as 0 plus 5 plus 5 plus 5. And now I'm counting the 3 plus signs instead of 2 plus signs. And 2 times 5 would be 0 plus 2 5s, and 1 times 5 would be 0 plus 5. And 0 times 5 would be 0 without any 5s. So 0 times 5 is 0. The same thing as I got with the concept of 0 is nothing. But if I go to exponentiation, I get 5 to the 3rd power is 1 times 5 3 times. 5 to the 2nd power, 2 5s. 5 to the 1st power, 1 5. And 5 to the 0, I'd be left with the 1. The right answer. So I have a lot less changing and adding additional rules with looking at 0 as its properties, because it's the number that precedes 1. And 1 is not so perfect either. We saw the trouble I had when I was doing modular arithmetic with the 1 around a circle. But if I raise 1 to a fractional power instead of an integer power, in this case to the 1/3 power, I got 3 answers. To the 1/4 power, I get 4 answers. And to an irrational number, I'd have an unlimited number of answers. So now what we've looked at is we've now questioned why we say that 0 is nothing, though it can be valid in the sense that that old young woman was valid. But we also then discovered that 1 has to be looked at carefully, because we would find out that if we use 1 to the infinite power, that it can end up being a number called E, which is 2.71828, which is definitely not 1. Think of it as nothing limits our understanding of numbers. As you can see, I viewed 0 very differently from the way it was shown in 0 to infinity. I used what I was taught to try to refute the discussion in this video. As I continued my quest for understanding mathematics, I could understand why math was not taught correctly, why some people could not learn it, and why others could. I have extended this approach to develop new ways of teaching math, which I believe are more effective. The beauty of this approach is that as it is used to teach math more effectively in the past and present, it can be taught along with the existing approaches by using the old approaches as an alternative to solving problems. Thank you for listening to me for these last few minutes.